All right, here we are. This is the fourth and last installment of the gas laws that we will be working with. Here you will see the problem says to calculate the volume in liters of 0.01700 moles of a gas at 32 degrees centigrade and at a 0.750 atm pressure. So whenever we're doing these problems, we have to remember looking at the relation of what they have given me. They have given me a lot of information. I got to calculate a volume. They've given me moles, a temperature, a pressure. And a lot of times people are confused and want to say I'm working a combined gas law problem, but it only gives me three factors and it has no matching factors for any of them. And this time they gave me a mole. There was no moles required before when we were doing gas problems. So now we know we're going to be working with ideal gases. And the ideal gas formula is PV equals nRT. Well, a lot of you may say, okay, I see volume, I see moles, but wait a minute, where's moles? Moles is notated by the lowercase n as in Nancy. We have a temperature, which is T, and we have pressure, which is an ATM. So let's take a look at this, and if we need all these things, let's determine what we should be plugging in. Okay, P, V, N, R, and T are the things that I need to be shopping for. Okay, pressure, they gave it to me. Okay, calculate the volume in liters. So that one I have no clue, and they want it in liters. N are the number of moles we're working with. R, we're going to put a pin in that and come back to it. And then we have T for temperature. And we all know in order to work gas law problems, temperature must be in Kelvin. So in order to do that, we're going to make sure that we use the conversion factor of 273.15. So we're going to add that to our degrees Celsius. So we're now going to end up with 305.15 Kelvin. Now, I know you said, hey, you put a pin in this R. I did. R stands for the constant. When dealing with ideal gas law problems, this is going to be the constant. This is going to be the one thing that no matter what ideal gas law I'm working, this is going to be the one thing that's going to be the driving force to make sure that I have all of my units in the correct version and making sure that I'm working the problem out to the best of my ability. So let's take a look. R as a given is 0.0821. Okay. Now here comes the unit for this number. Liters, moles, ATM, Kelvin. We now see the importance of making sure all of our problems are in the correct unit, because if we're plugging and chugging and canceling like terms, if we don't have each of our variables in the correct term, we cannot cancel out the units necessary. So it lets us know that ideal gas laws have a direct relation between the pressure, the volume, the moles of what you're working with, the temperature where this is, and there is always a given constant. So if we're solving for V, we need to conjugate or change this formula. So we're going to solve for V. V equals nRT divided by P. Okay? And this is all supplied to you in your formula worksheet. So make sure to look at those when making your list and going ahead to start your plug and chug. So let's go ahead and start filling these in. So we know our N, okay, our R, and yes, we must write all of these units. Our temperature, and then we're going to divide all of that by our pressure, which is going to be 0.7508. Okay. Before we do any work, we're going to go back and we're going to cancel out, making sure all of our like terms are canceled out and we're left with just the unit we should be solving for. So we don't want to make a habit of just crossing things. We want to be meticulous. So we're going to start here in our first set, mole and cancel mole. Okay? We come to ATM. There's another ATM in the problem. And then there's Kelvin here at the end. Once again, we are left with liter, which is the unit that the question is asking for. So let's go ahead and do our multiplication, okay? And we do not do any rounding until the very, very end of our problems because we can neither create nor destroy matter. And if we round before the problem is done, we have destroyed matter. So let's go ahead using your simple calculator, multiply all of your numbers across the top. I'll give you a moment to do that. Okay. Once we do that, we must divide it by the pressure on the bottom. There was no math to do there. So once we go ahead and plug that last problem into our calculator, we are then left with 0.5678637 liters. And I don't know about you, but I would hate to have to be that precise in how much of a liter that I'm getting. So we're going to round that, let's say, to the tenths place again. So we're going to look at the hundredths place there. Okay, so remember we're going to look at the hundredths place and we will be left with 0.6 liters. And that is the combined or ideal gas law.